All right. Hey, you got a video lesson today because depending on which class of mine you're in, I am out in a meeting. So most of you will be able to have me teach this to you in person, but I believe fifth period for sure will have me just teach this to you via video. So here we go. I will hopefully have already warned you a day ahead of time to have your headphones. So this is 4-7, linear and nonlinear functions, page 327 in your workbook. And here's our short notes page that the sub will pass out to you. In a previous lesson, you learned that linear functions have graphs that are straight lines. Yes, we know that. This is because the rate of change between any two data points is constant. We also know that. Nonlinear functions are functions whose rates of change are not constant. Therefore, their graphs will not be straight lines. So nonlinear, not constant. That's what we're going to test for today. Determine whether each table represents a linear or a nonlinear function. Well, when we were testing for linear way back when in the beginning of chapter 3, we learned to check and see how is y changing? How is x changing? And we were finding our slope. What we were really finding is the change in y over the change in x. Right? That's actually rise over run, which is slope, okay? Well, if it's constant and you always have the same answer, it's linear. But if it's not constant, it's not linear. So we'll look closely here and see how is y changing. So it's going down by 4 every time. And how is x changing? It's going up by 5 every time. Okay. And so that means when we stack that change in y over change in x, we've got -4 over 5, -4 over 5, -4 over 5. They are all equal. And so the answer to this is, it says determine whether it's linear or nonlinear and explain. So this is linear. There is a constant rate of change. Okay. Moving on to letter B. We're checking again, is this linear or nonlinear? So how is y changing? How is x changing? Tested as the change in y over the change in x. You should pause the video here and do it on your own and see if you get it right. +2, +6, +10. Now, don't be assuming that just because you checked this, that this means it's not linear. Okay, you have to actually compare the fraction, change in y over change in x. Some of them are tricky. But this one you can clearly see, okay, 10 over 2, well, that's 5. And 6 over 2, well, that's 3. So this is not constant. So this one is nonlinear, no constant rate of change. Okay. All right. Moving on to our word problem example. Tickets to the school dance cost $5 per student. Are the ticket sales a linear function of the number of tickets sold? So we've got our data over here, but we could have figured it out on our own, right? 1 student, $5, 2 students, $10, 3 students, $15. And so this is going to be constant, right? Because you're going +5 every time, +1 every time. So this is linear. And it has a constant rate of change. Or I can just say a constant rate of $5 per person. Okay. One more. Let me see if I can fit the whole thing on my doc cam here. Okay, and I'm going to quickly, I can't pause it on this program. So I'm going to quickly draw a table, and I'm going to do a 3-column table, and you'll understand why in a minute. So pause the video if you need to draw a quick 3-column table as well. Okay. A square has a side length of s inches. The perimeter of the square is a function of the side length. Does this situation represent a linear or a nonlinear function? So basically, we have to figure out side lengths and perimeters and the data for that before we can make a decision on this. So we're going to go s Okay, and then here we have perimeter equals 4 times s, because this is a square, right? So on a square, you add up all 4 sides to get your perimeter. So our side length, okay, is our independent variable, because depending on our sides, times 4 will equal our perimeter. Sorry, not our sides, our side length. So s is side length, and then p over here is perimeter. And I did a 3-column table just so we can do some quick math in the middle. So we're just going to test, let me put some more lines in here. Geez, I couldn't even draw a straight line with a protractor. Almost. All right, so we're going to do a side length of 1 inch, 2 inches, 3 inches, and 4 inches. Because we can't have any negatives here, right? Because this is actually geometry. This is side length of a square. You can't have negatives. So we're not going to use the inches when we do our math, but we will use the inches when we do our answer. So perimeter equals 4 times 1. Well, that means P equals 4. How many? What is it? It's inches. Perimeter equals 4 times 2. Okay. Pause the video, finish it on your own. 8 inches. Perimeter equals 4 times 3, 12 inches. Perimeter equals 4 times 4, 16 inches. Now all this was us just calculating data. We haven't answered the question. The question is it linear or nonlinear? Well, here's where we check how is our x changing. Here's where we check how is our y changing. And it's going up 4 every time. Plus 4, plus 4, plus 4, plus 1, plus 1, plus 1. So this is a linear function. Okay, and you can say the constant rate of change, or the constant rate, is 4. All right. And that takes care of your notes for the day. Take a look at your agenda. I honestly, the day I'm recording this, I don't remember what I have for your CYU, but take a look at your agenda online, and I should have given the sub-directions to make sure that you checked your agenda online and to see what your CYU is for today. All right, you guys, I'll see you soon. Bye.